The next one, based on the schedule, also the presentation with where I'm take a part, and let me to let me to share the results uh, of another work. This work is based on the uh, FPGA development, and during this work, we with co-author um, uh, performed the research of problems with the process of support of the systems during the change of the requirements to the system, during the change of the uh, environment, integrated environment, the exact platforms and targets or target devices, and we analyzed the experience over 10 years of development using different technologies and different vendors of FPGA, and we propose a solution for preparing of projects tolerant or stable to the change of requirements and change of the vendors. And we want to share such results with you. So we focused on the analysis of existing and proposed environment and development tools from Xilinx. And in previous our research, the tools and uh, specific of usage of such tools from Intel and Altera was considered. So based on the current analysis, it's possible uh, to focus on the main main features of the porting of the project. But to do it, it's necessary to consider the reasons why the problem exists. The problem is based uh, on the changes in the companies at all, and uh, during the last decade, all companies or vendors of FPGA were rebranded or maybe changed the general company. And as we know, the Altera company, Xilinx company, and Actel, and then Microsemi now are another companies. It's interesting to check this process, because some kinds of integrated development environment changed also, but with some support of older projects, but sometimes no. And the biggest FPGA vendors and companies also are the biggest companies that produce the chips, and it means that they are using the most maybe uh, complicated process, technological process for production of their chips. But based on the analysis, the Xilinx company is the biggest company, at least for the moment, begin or before the COVID. And based on that, in the current research, we uh, focused on the products of this company. So the main goal of our research is reducing efforts of the developer for reprogramming and modification of the projects during the process of migration of the project to another environments and another requirements, and at the end reducing the efforts to prepare some products that can be used during the infinite process of changing of requirements and environments. And we performed the analysis of the most or significant changes of the environment from Xilinx company. Let's consider the history. As you know, starting maybe at 2014, the IC tool transformed to Vivado tool that is still valid for the embedded development for Xilinx FPGAs. But in 2016, this company proposed the technology of the on the run reprogramming of systems using the SDAxle tool that helps developer to reduce the efforts for the communication with the PCI Express cards. And in this case, the efficiency of the maybe programmer time is higher. But the problem is that this tool was completely replaced by another tool named Vitis with some kind of compatibility between them, but not directly. There is no any option to import of the project from SDAxle to Vitis. Another problem is that there is no compatibility between different versions of SDAxle and Vitis tools, and it means that it's impossible to perform the porting of project between Vitis 2019 to 2020 or 21 or 22. It's not working directly, and it's possible to perform recreation of the project that requires maybe a lot of steps depending on the complexity of this process. And this is a significant problem on the one hand. On the other hand, SDAxle and Vitis propose the usage of XRT framework that significantly simplifies the process of communication with the PCI Express card. And for the end programmer, the process looks like the calling of the function. So for the programmer, it's definitely easier to use the version of some version of XRT framework to perform the programming of the FPGA card. But the problem is that each XRT version is incompatible with another XRT version, and the Vitis as the environment for the development of the projects with this XRT framework is incompatible with another versions of the frameworks. It looks not too comfortable for the developer, but again, for the developer, it's important to have some simple process, and everything looks not too bad if the developer just want to use the newest version of the development environment and the development tools. How looks the process of communication between the FPGA and host parts for the developer? It's necessary to take into account that normally the FPGA system can be considered as the center of the development itself. But here, the paradigm should be changed, because in such systems, FPGA can be represented just like a function or some kind of accelerator. And in this case, for the developer, the process of communication looks like loading of the binary of precompiled kernel to the FPGA card over PCI interface. Just one line of the code at the host program. Then another function starts the running of the FPGA kernel inside the FPGA and wait for the result from the FPGA kernel. Technically, this is a significant change because it's possible to perform a lot of such iterations per 1 second. It means that it's possible to perform reprogramming of the FPGA few times per second, maybe 10 times per second, with completely different functionality, perform some computations inside, and return back the data and maybe result of such computation. This is a significant change of the paradigm, and it's necessary to take it into account. It's important to know that the changes of the appearance of such development environments, is significant with changing from one version to another. It requires a lot of efforts from the developer to perform the configuration of the project because all the windows at the environment change it and change it significantly. Sometimes there is no such option in the new version, and it's impossible to perform such kind of configuration of the project. It's confusing, and it's not easy to get the idea of the company itself, or why it was changed. But during the 10 years, we can conclude that 4 technologies of development from Xilinx was replaced by new one. And it means that if there is some project with long support term, it's necessary to perform some kind of project that can be ported from one to another environment. It's not a problem for the developer if they are using the newest version of the environment, but here there is a pitfall, and the problem is based on the development boards. The problem is that there are a lot of Alveo FPGA PCI cards, but they are dedicated for exact firmware that was pre-installed to some components inside the circuit with FPGA. And as a result, each card supports only the exact XRT framework version. But the Whitis and SDXL development tool also support the exact version. It means that the card is connected to the exact version of the XRT and exact version of the development tools. Such card is based on the modern FPGA chip with efficiency compatible or higher than GPU chips, or modern GPU chips, or graphical adapter. And as a result, such cards can be used as an accelerator for some dedicated tasks, and we will consider such examples. But the problem for the developer is that during the development stage, the engineering sample card will be produced first. And exactly this version will be used for the development of the project. And because of that, all the features of the project will be tested on this development environment with modification ES, or engineering sample. but after the release or before the release, it's necessary to move to the release version of the card that has some better features. But the problem is that this card with the same name, but can be based on another chip with another firmware and with use of another XRT framework version. As a result, it's necessary to perform the reprogramming and moving of the project to another environment. This is a really big problem because sometimes new features of the XRT framework prevents of implementation of the previous project. And it means that sometimes the concept is completely can be implemented using another card with the same name but without some postfix of engineering sample. This is the problem, and let's consider the simplest card or cards U25 and U50, and they are also has some problem with their normal performance. The problem is that they are developed for the data centers with centralized cooling, but they can be installed to the normal PC. And the problem is that the user can install such card and run it with the same efficiency that he expected from the normal card. And the result is that it's impossible to run them because they will fail you after that.
Dear,
Let me 3 minutes
we
to
left from the time. Please keep the time. Have
okay.
some minutes, okay?
Okay. Well, as a result, during 4 years of the development, from the moment of the release and to the current moment, all the cards that was produced by Xilinx now are not compatible with the modern development environment. And this is a real problem because it's impossible to perform the support of those cards. And even the support team proposed to avoid the usage of their card and strongly recommend to use the new U55C card. During the comparison with the features of with the previous card, it's possible to find that there is no significant difference between them, except the size of the memory. The 16 gigabytes of the inbuilt HBM memory is available in this card, but technically there is no difference, and the previous card has some significant advantage against the new one in the performance. But they not support this card anymore. Based on that experience, it's possible to propose the following steps of the prototyping of the systems to avoid the problem with the movement to the new platform. And it's proposed to use best practices during the usage of the development environment and during the preparation of the projects, and add some possibility of reconfiguration and maybe modification of the program that allows to perform the transfer to new versions. Also, it's recommended to use a command line interface for programming of the project, because this is the best practice for such process, because it will help to avoid the problems with the graphical user interface. And it's possible also to use the direct communication with the company to check the next features of not published tool before it will be published. Also, it's possible to propose the following ideas of the optimization of the projects to improve the performance. And it's recommended to use some documents and user guides from the for the exact chip from the vendor to improve the efficiency of implementation and routing of the chip, and we propose to use 2 or 3 registers in a chain to improve the frequency and simplify the placement of the project. We also propose to use some tag during the pipelining of some RTL-based projects to perform the identification of the data inside the chip, and in this case it's possible to perform some asynchronous processing and out of order processing of complicated processing systems. And also we propose to use the mapping of the exact part of the project to the SLR, or super large region inside the chip. Here's the exact or some case study of such process where the possible part of the project was found. This is the part, and this part was moved to the SLR 0, super large region 0, that is connected directly to high bandwidth memory in the chip. And using this modification, the final frequency for this project was improved by means of the reducing of the connection between the different super large regions in the chip. As a result, we obtained the following result of this work, and we proposed 2 different sequences as a part of the technique of the prototyping of the projects that are stable and predict the possible changes of the environment. Thank you for your attention, and I will ask for any question. I will answer for it.
Thank you very much for your presentations. Yes, thank you very much. Any questions, please? Any questions? Thank you. Yes, it's very specific work you've done. You with colleges is very nice, very special. So you propose modification of planning of FPGAs, as I understand.
Yes. We propose 2 sequences that helps to build such projects that tolerant to change the environment and not requires a redesign.
Yes.
If the new version of the environment is published. Yes.
Yes, it was very nice, very nice. And your simulation you done is on what platform?
This is the chip viewer using the Vivado development environment from Xilinx for his targets and chips. And here it's possible to see the exact placement of parts of the project inside the FPGA chip that consists from 3 separated silicon die connected together using some interconnects with limited number of pins. So actually this is a view of 3 chips inside single package.
Very nice. Very smart idea, yeah. Also, you're working with the RISC processors or no? Only with the FPGAs?
Yes.
Because RISC processors, they have a lot of advantages pipelining that you make it now here.
Yes, and it's clear why, because this kind of processor has some dedicated set of commands, and it's possible to organize the pipelining using this set of commands because it's specific.
Yes.
Yeah.
Yes. Excellent. Very nice. Very nice. A very specific work you've done. Very nice. Thank you. Any more? Okay, thank you. Let's go to the next one, presentations.